spectrometry is a technique that's just over 100 years old, and it involves weighing molecules. In order to weigh molecules, we first have to put them inside something called a vacuum chamber, where there's hardly any air. Because if we did have air there, they would collide with the air, the molecules we wanted to see, and we wouldn't be able to see them. So we put them inside a vacuum chamber, and then we do something else to them. We make them charged. We make them a particle that we can deflect with the application of an electric field. And so I'm going to simulate how we do that experiment with these balloons. So these balloons, each of them have got a molecule on them, and these are sorts of molecules we have in everyday life. So paracetamol, that's what people might take if they've got a headache. Glucose, that's a form of sugar. And caffeine, that's what you take to get a headache. And so each of these balloons represents a molecule. And in order to make them represent the different weights of these different molecules, we've laden these balloons down with glue tack. You can just see that there. And so what I'm going to do shortly is let go of these balloons, and they're going to fly up as they would if they were ions in a mass spectrometer. And the heavier ions are going to take longer to get to the detector, which is sitting at the top of the ceiling here, than the lighter ions. So now I'm going to ionize them, I'm going to knock an electron off them and turn them into ions, and this floor has got a big positive charge on it, and these are positively charged, so those two positive charges are going to repel one another, and the molecular balloons are going to be flying up. So here we go, let's ionize them. And we can see the very light balloon hits the top first, and the heavier ones get there later. The heaviest of all, being cholesterol, got there the last.
Ion mobility mass spectrometry is a hybrid technique that consists of two techniques: ion mobility spectrometry, which measures the movement of ions in a gas, and mass spectrometry, which measures the movement of ions in a vacuum. Both techniques were invented around about 100 years ago in the Cavendish laboratories in Cambridge. They then continued as analytical techniques separately. So ion mobility spectrometry is used a lot in security and defence and monitoring applications. It's the technique that's used to sample from your laptop, from your phone, from your hands. As you go through an airport, if they wipe that white wand over you, take it over to usually to a grey box, what they're doing is ionising the molecules that have been on your phone or on your hand, and measuring how quickly they move through a gas to see whether those molecules are banned substances like narcotics or explosives. Mass spectrometry, which measures the mass of molecular ions, is used for a lot of monitoring, particularly, for example, monitoring whether athletes have taken drugs that are illegal. It's also used to check for adulteration of foodstuffs, and increasingly it's used in biological and in healthcare applications to determine the amount and the type of proteins that are available in all sorts of biological systems. The combination of the two gives us a really exciting and powerful technique where we can not only tell the molecular composition of a particular analyte, but also measure its shape, all in the same time, all in the same experiment. And so what we use it for is to measure the shape, the size, and the packing of protein subunits. For example, as proteins start to aggregate, which they do in neurodegenerative diseases, in the end causing deleterious fibrils often in people's brains, we look at the early stages. We look at how the proteins start to change shape and start to accumulate. And the reason we want to do that, we do it in an ion mobility mass spectrometer, is we want to find out what sort of drug molecules might prevent that aggregation, then preventing the onset of that disease. So combining mass spectrometry, the measurement of mass, and ion mobility spectrometry, the measurement of shape, gives us this fantastic tool which we use in many applications, and particularly now in biological ones.
We are in the lab with real mass spectrometers. So of course the molecules that we previously had these balloons for actually go into big machines like this, and the noise you can hear in the background, that's the sound of the vacuum pumps taking all the air out of the machines. So this laboratory has 8 mass spectrometers in it, some of which we've developed. Here's Ellie here taking mass spectrometry data on a protein DNA system.